Alright, welcome kiddies to your last video lesson for this chapter. Today we are going to talk about functions, which is what we did in the third lesson, and we're going to focus today on graphing. So you're going to have a little bit of a review on how to plot points from a table or an ordered pair onto a graph. Whoa, and I just found this little tool out that can put me on the screen, except I don't know where. I think I look right there. Is that where I look? Is that right? I think so. And look at, hey, we got a little visitor today. That's my little puppy. Say hi, little puppy. Hi, Algebra 1 class. Hey, look out the window now. That's my little doggy. All right, enjoy, kids. I'm going to get off the screen now because this is creeping me out. Oh. Okay, enough of that silly business now. Let's talk about functions. So we talked about last week that functions represent a relationship between inputs and outputs. Okay. Again, I showed you this little idea of a function as like a machine where you plug something into my little function and you get something else. You have an input and you have an output. So today we're going to talk about how do we represent functions. Well, there's really three ways. The first way we looked at last video, and that's talking about a table, right? We talked about functions as tables and how to read these as inputs represent all the x values, outputs represent all the y values. So we can determine a relationship from there. Second way we could do is something you might have seen before in the past is an ordered pair. Okay? In an ordered pair, I'm not talking about a fruit of a pear with a bow tie, not an ordered pair ready to go to the ball, but instead I'm looking at an ordered pair of inputs and outputs. Basically, an ordered pair takes these values of 3 and 6 and 1 and 4 and 5 and 8 and pairs each input with its output. Okay? So looking at an ordered pair, the 3 represents the input or the x and the 6 represents the output or the y. So in every ordered pair, the first number that comes first is the x, second number is the y. And the second way we're going to look at this is through a graph. Once I have my table and my ordered pair, we can now represent this relationship on a graph. For example, my first ordered pair, I know that my input is 3 and my output is x. So on any graph, and you might have a background knowledge on this, we have two what are called axes, a horizontal axis and a vertical axis. The horizontal axis is known as the x-axis. This is where all our inputs go. Vertical axis represents our y-axis. That's where all our outputs go. And by putting our ordered pair on this graph, we are able to see an overall relationship of all the ordered pairs, of all the inputs and all the outputs. For example, I can plot the input of 3, which is my x, and for that input of 3, we have an output of 6. So I know that I have a dot that represents this ordered pair. Second one, I have 1, 4. So 1, my input's here. 4 is my output, which is there. So 1, 4 goes right there. And then the last one, I have 5, 8. So 5 is my input. 8 is my, right there. 8 is my output. All right, so that is going to go right there. Now, based off of how those points look, what I can do is then develop a relationship. Okay? So I have 3 points. You can kind of see what happens in this graph. Oh, whatever's happening here, you can see the points are going up and to the right. Oh, up and to the right. So from this graph, I'm able to infer a relationship between my inputs and outputs. And that's what we're going to study later on this semester. But our focus today is to be able to take a table, being able to write those things as ordered pairs, and then being able to graph the overall relationship between inputs and outputs. Alright, so let's take a look first at a function. So I have the function here of y equals 1/4 x. Remember last class we talked about what's called a function rule. This right here represents that specific function rule, 1/2 x, where x again is my input and y again is my output. Okay? And it wants me to graph this function given the domain of 0, 4, 8, 12. Now what is the domain? Ooh, that's a term from last video. Interesting. Well, wait a second. Isn't the domain all the inputs or the x values? Why, yes, of course it is, right? It is. And my doggy in the background just said, of course it is, silly Nellies. Okay, so then she said it. That means it must be true. Okay? So what do I have to do? Well, if my inputs are all x in order to graph this, what we just said is I need an ordered pair. I need an ordered pair of x and y. For every input, I need to know my output. Well, I don't know any of the outputs. I don't know the outputs, y, which we also call the range. Interesting. So how the heck do I find those values for the range? Well, inputs to find my output, maybe I take my input and plug it into the function. Interesting how that works. So I'm going to do that in the space provided right here. I'm going to take my inputs of 0, 4, 8, and 12, and I'm going to take these and plug them into my function rule for x. So, first one, I'm going to plug in 0, so I have y equals, I'm going to leave y because y, remember, is my output, 1/4 times 0. 1/4 and x are written next to each other, so that means multiplication. So what's 1/4 times 0? Oh, geez, we got a fraction, but nevertheless, that's 0. So as an ordered pair, I'm going to write this off to the side. When x is 0, y is 0. That means when my input 0, my output 0. Next one, y equals 1/4. Oop, that's a half. 1/4 times 4. Okay, equals what? Well, now we got to think about fractions times a whole number. How do I solve this? Well, just real quick, one way to do this is when you multiply a fraction by a whole number, you can put that whole number over 1. So then what I have here is 4, multiplying across, I have 1 times 4. 4 times 1, that is going to give me 4 over 4, which equals 1. So that means this ordered pair has an input of 4 and output of 1. Okay, next one. Y equals 1/4 times 8. I'm going to show you a different method on this one. We can do the same thing. Put this one over 1, 8 over 1. Now, instead of multiplying across and simplifying from there, I can cross-simplify. So 4 goes into itself once, goes into 8 twice. Then I can multiply 1 times 2 is 2. 1 times 1 is 1. 2 over 1 is 2. That's going to give me an ordered pair of 8, 2. And then lastly, plugging in my last y or my last x value, I'm going to have 1/4 times 12. You can do any method you want here. I'm going to put 12 over 1. I like to simplify, so 4 goes into itself once, into 12 3 times. I get 3 over 1, which is equal to 3. So when my x value or my input is 12, my output is 3. Okay, so I have in total these 4 ordered pairs that show for every input the specific output. And notice how for every input I am getting 1 output. That means what? If I have 1 input or 1 output for every input, that means it's a function. That's one rule we talked about last video. Okay, so now plotting these points. First input is 0, output is 0. My doggy's going nuts. Hold on one second, folks. Okay, that was my mom who stopped by. She just wanted to say hello to everybody. Make sure everybody's doing just perfectly fine and dandy tonight. Just bringing up my little doggy one more time. She wanted to say hi to everybody and apologize for interrupting. She says, it's okay, guys. I'm sorry. It won't happen ever again, please. And now we're back. So we left off. We plotted the point 0, 0. My input 0, output 0, so boom, there. Next one, I have my input of 4, output of 1. I'm going to put a point right here. Okay, then I have a next input of 8, output of 2, boom. And last one, input of 12, output of 3, boom. Okay, now, can you see a relationship? Can you look at the graph and kind of tell what's going on? Oh, that as my inputs go bigger and bigger, what happens to my outputs? They also go bigger, right? We could then connect this with a line that connects all those points, and notice how that line increases, has kind of a slope to it. We're going to look at that later on, all right? But now our focus is just graphing and see if we can determine a relationship from there. All right, next example, we have this table showing the average score on math section of the STAR test, which you guys just took, for CHS from 2006 to 2011 as a function of time. So as time goes on, we're going to see what happens to the average score. So what I want you to do is, given this table, graph the function. So last example, I gave you a function rule. This one's a little easier because I give you the table. So it tells you that, here's the key thing, that it is the scores here, the average score, as a function of time. Now that's something you have to pay attention to and have to read it carefully. When you say score as a function of time, all right, The score depends on what the time is, what year, right? The score depends on the year. So if it depends on the year, think about it. Which one would be the input, which one would be the output if the score depends on what year we're in? In this case, the input is going to equal the year, and the output is going to equal the score. Because depending on what year it is, the score is going to be whatever it is in that specific year. Okay? So that means my years is going to be my X, and my average score is going to be my Y. So on my graph over here, again, X is the horizontal, Y is the vertical. I'm going to take each one and plug it in. Now notice, what do you see about this graph? Let's take a second here to zoom in on the graph. What do we notice? Okay, there's no labels on it like the last two graphs we did. Okay, so this one we have to actually label our graph. So let's talk about this really quick. All right, in order to label the graph, we have to look at our table. Our years go from 0 to 0 to 5. So on my graph, I'm going to label my x-axis, which represents years. I'll just give it a quick label. And I know it goes from 0 to 5. So I'm going to start from 0, and I'm going to go by ones up to 5, and heck, I'll just continue all the way through to 6. So I labeled my Y, or my X's, my years. My Y's represent the average score. Now, if you look at your scores, what do you notice? It starts at 68. Now, common mistake for people to graph here is just go every box, 0, 68, the next one, the next one. When you graph things, ladies and folks, you need to have what's called an even scale, meaning that every grid you go up, you have to go up by the same amount every time, whether it's by 2s, 5s, 10s, whatever. So what scale am I going to choose? Well, I'm going to look at my data, right? I'm going to look at my outputs. Okay, I see it starts at 68. Now, for you guys, you may have learned on a graph how to do a break. I don't like breaks. Breaks are when you cut off the graph from the start and start at some random number. I don't like that. So I want you to start from 0 and have a constant scale. So looking back at your data, you go from 68 to 82. Right? So what I'm going to jump by, and I kind of predetermined this by looking at my graph and the number of boxes I had, I'm going to go up by 10 every time. So I'm going to go 0, 10, 20, 30, excuse me, oh my gosh, 40, 50, 60, 70, and 80. And heck, thinking about it, maybe I should go up to 90 since my last one's 82. Alright, now what I'm going to do is just I'm going to zoom out a little bit, so sorry about moving the screen all over the place. Now I'm going to take my inputs and outputs and plot them. Okay? So, first one I have 0 in the year, I guess 0, which is, might not make sense, but really we're talking about our first year here is 2006. So in 2006 or 0, we had a score of 68, which I'm going to put really close to 70. Okay, kind of estimating there. Excuse me, holy cow. Year 1, we have a score of 73, so I'm going to go from my input of 1, I'm going to go up to about 73, again, somewhat estimating here since I'm using a constant scale. 274, so what do we see there in year 2? It doesn't really go up that much, okay? So we got some real data here, so we're not going to see such a smooth, straight line like we saw in the last graph. Year 3, we have 77, so that went up a little bit. We're close to 80 there. Next one, we had 78. Okay, so I'm just moving over, went up a little bit. And the next one, 82. Okay, so I'm kind of jumping across. I'm not really showing you all the inputs and outputs. Now this one, we think of that, well, last time I said, okay, think of a line. What do we see from the data? It's not really drastic, but what do we notice about the scores in math? Okay, I kind of drew that blue line on there between the points. Oh, notice a little bit of an increase there, huh? Little upward slope. What does that mean, folks? If there's a little upward slope and just looking at the scores, things are going up, I tell you. That's because you got fantastic math teachers at Cudahy High School. Keep it up, guys. All right. So again, what we did here is from our table, found our inputs and outputs, plotted them, graphed it, and then we were able to see a relationship between the two things. All right, last example here before I let you try some. This one we're going to do the opposite of what we did in the first problem. I want you to make a rule. So what do I mean by a rule? I want a y equals x kind of rule where something is happening mathematically to our input that is then going to determine our output. So from this, I want you to look at the graph to figure out this rule. Okay, so what's going to help us here is maybe doing some techniques we talked about within this video. First of all, I give you points on a graph. So from these points, heck, first thing we should do, maybe write down the ordered pairs. This first one I have an input of 1, output of 1. Next one I have an input of 2, output of 3. Next one I have an input of 3, output of 5. Then I have an input of 4, output of 7. And lastly, input of 5, output of 9. So within this problem, I'm asking you also to identify the domain and range of the function. So right away, given these ordered pairs, remember that I know the first number is my input and the second one's my output. So right away, let's just label our domain and range. Our domain, folks, using my squiggly brackets, are all the x values, all the inputs. So I have 1, 2, 3, 4, 5. This can just help me when I get to my rule. Then I have my range, okay, of 1, 3, 5, 7, 9. Okay. It's going to be interesting here. Oh, doggy has a scratch. Hold on. There we go. We're good. All right, so looking at my domain and my range, I want to figure out what's the relationship. Interesting. So the first one, here's what I have. I have my input of 1 and an output of 1. Well, whoa, what happened there? My input's 1, my output's 1. Oh my gosh. Okay, well nothing changed there. That's interesting. So maybe I'm just multiplying by 1? Well, let's check the next one. If I multiply by 1, does that work here? No, 2 to 3, that doesn't. 2 times 1 is 2. Okay, so what could happen here? Well, let's maybe try and look at 2 to 3. 2 to 3, I'm adding 1 here. I'm going adding 1. Let's try that. Add, 2, shoot. Okay, dang it, this is not working here. This is not working. Well, maybe I got to do a little combination of things, right? Okay, well, let's take a peek. Let's take a peek. Let's take a peek. What can I do here? Well, maybe I got to do some sort of multiplication. Okay, so let's say I take my x. Let's say I take one of my inputs. Let's try the input of 1, and let's multiply it by something. Now, multiplying it by 1, I tried already. Didn't do anything, so maybe let's multiply by 2. So if I take 2 times 1, that's going to give me 2. Right? Now, with my input of 1, I want to get an output of 1. Well, right now, 2 times 1 gives me 2. So let's think, if I multiply it by 2, how can I get back to 1? Maybe if I subtract 1 from it. And that's going to give me 1. Okay, so let's try that for the second one. So let's say I take my input of 2 and multiply it by 2. So again, right here, let me put it in red. These are my inputs. So 2 times 2, that is going to give me 4. Now the rule I came up with is let's try and subtract 1. Does that give me my answer of 3? Well, yeah, it does. Look at 2 times my input of 2 minus 1 gave me the output of 3. So there's my rule, folks. Just by looking at the first two, I've kind of figured it out. I'm taking 2 and multiplying that by my input of x, which x, again, is anything in my domain, and I'm subtracting 1 from it. And that is giving me my output y. And there's my function rule. This one's a little sassy, folks, okay? So when you can't add and subtract like we did in the last video, you might have to do some sort of combination of multiplying and adding and subtracting. Lastly, folks, I want you to try these two problems here. The first one, given the function rule of y equals 3x minus 2 and this domain of 0, 1, 2, 3, 4, graph the function. Number 2, write a rule for the function based off of what you see in the graph. Remember, this is just like the example we just did. Find some ordered pairs and see if you can figure out the relationship. All right, pause the video. Give these a shot. Okie dokie, artichokes. First one was easy. Second one, I realized there's a little error on your, well, it might be different on your notes than it is in the video, so I apologize for that. So if you didn't get the second one, that's okay. So this one we have function rule y equals 3x minus 2. Here's my domain. So just like a problem we did earlier, I'm going to take every one of my domains that you get into my inputs, and I'm going to plug them in for x in my rule. So here I do that, and I get my ordered pairs 0, negative 2, 1, 1, 2, 4, 3, 7, 4, 10. Graph on the left. Sorry if the page shifted a little bit, but boom, there was a dynamite. There's my graph. There's one point you couldn't graph. I'm going to put a red cross here right now. 0, negative 2, I didn't give you a graph that had enough space. So you couldn't have graphed that one, but every other point you should be able to graph. Second example. All right, I, on my notes, accidentally cut off the bottom scale. And being the dingus that I am, I forgot to bring my notes home with me. You know what I'm saying? So I'm assuming it's 1, 2, 3, 4, 5. If it's different, we will go through it in class, but just follow along what I did. It's the same process. Here's what I done. From the graph, I put the coordinate points, or the ordered pairs. 0, 2, 1, 2.5, 2, 3, 3, 3.5, 4, 4, and 5, 4.5. All right? So if you look at over here what's going on, it goes from 0 to 2. You're trying to figure out what the rule is. Well, 0 to 2, right away, you can't multiply anything by 0 because, well, you can't get 0. You can't get 2 then if you're multiplying by 0. Okay, so thinking you can't multiply, you add 2. Well, okay, add 2. We'll go 1. 1 plus 2. Oh, shoot, I have this 0.5. 2 times 2 would give me 4, but I have this 0.5. 3 times 2 would give me 6, but oh, okay, so that's not going to work multiplying, or sorry, adding it was. 1 plus 2, yeah, that would be 3. 2 plus 2 would be 4. 3 plus 2 would be 5. Oh, man, okay. So that's not working. So here's what, again, you had to do. You had to think about multiplying. And really, to multiply, I took a look at this one right here. All right, I knew I had to get a 0.5. That's like a half, if you think about it. So I knew I had to get a half. So I thought, okay, let me just take 1. I just took the number 1 and I multiplied it by 1/2. Okay, I just multiplied because I knew that I had to get a half. I'll change this here. I multiplied my 1 by a half. And I know 1/2 times 1, if I do the math, is a half. Well, a half does not get me 2.5. So what I did then is I added to that half, I added 2. 2 plus 0.5, or a 1/2, is 2.5. So my rule, I said, okay, 1/2 times my input, and then add 2 to the end. So I checked. 1/2 times 2, well, half of 2 is 1. Add 2, you get 3. Oh! Half of 3 is 1.5. Add 2, 3.5. Half of 4 is 2. Add 2, you get 4. So notice how the rule works. So again, if your x values are a little different, I apologize. But again, when it's a little difficult, it's a combination of multiplying and adding. Some of these are fun because they're like puzzles. Right? All right, if you have any questions, I know this stuff might be a little challenging, especially with these last examples. Bring all questions to class. I'll be happy to answer them. Otherwise, good luck on the practice problems, and we'll see you guys next time. My doggy, I'm not going to pull up the video, but doggy says hello. Adios, folks.